morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking about using the Pythagorean theorem to solve some problems, answer some questions. It's one of the most useful theorems in all of mathematics. Let's get right to it, shall we? We need to know about our geometric figures here. This is a nice little summary in our textbook of the properties of rectangle, square, rhombus, isosceles triangle, and equilateral triangle. Notice all the right angles that gives us right triangles, meaning we can certainly use Pythagorean theorem with right triangles. You always want to draw a neat diagram of the situation, mark everything that you know, use variables to represent what you're trying to find or what you don't know. And then you just go for it. You solve the equation using Pythagoras. All right, so rectangular gate is 3 meters wide and has a 3.5 meter diagonal. Stop right there and draw a sketch. And label everything. And there we go. So 3 meters wide, so that would be here. And a 3.5 meter diagonal. Bam. So that's 3.5. How high is the gate? So I guess then they're saying that this is the 3 if this is the width. And so we'll call that x. And we know that a rectangle has all right angles around. So I have a nice little right triangle here. So I have x squared plus 3 squared is equal to 3.5 squared. Because 3.5 is the hypotenuse, and I'm using the Pythagorean theorem, a squared plus b squared equals c squared, where c is always the hypotenuse. Okay, so I get x squared plus 9 is equal to 12.25. And subtracting 9 from both sides, I get x squared equals 3.25. And then finding the square root of that. Take the square root of both sides. X equals the square root of 3.25. Normally, I would write plus or minus out here in front of this, but since this is a length, I know it can't be negative. And so x is approximately equal to, let's see, 1.80, I believe, rounded to 3 significant figures. Okay, next. A rhombus has diagonals of length 6 centimeters and 8 centimeters. Find the length of its sides. Well, a rhombus has all sides equal. Looks like a diamond, generally. So there's a rough sketch of one. So all the sides are equal, and it's telling me that each diagonal, or it has a diagonal of length 8, and instead of labeling this 8 right here, I'm going to do it here. Okay, and then it has another diagonal of length 6, so that would be from here to here. Now we know 2 things about the diagonals of a rhombus. They are perpendicular and they bisect each other. Okay? So in other words, from here to here is equal from here to here, and from here to here is equal to from here to here. So that means if from here to here is 8, half of that must be the length from here to here, or 4. And if this entire length is 6, half of it is of length 3. And this is one of the sides right here of the rhombus, so I'm just going to label that as x. And you'll notice we have a nice right triangle there. Bam. And this is 3, and this is 4, and I'll call this x. And this is the most famous of the Pythagorean triples here. This is going to turn out to be a 5. You'll hear this reference as a 3, 4, 5 triangle. But we'll solve it anyway. We know that 3 squared plus 4 squared is equal to x squared. 9 plus 16 equals x squared. 25 equals x squared. Find the square root of both sides. Again, we can ignore the negative, and x is equal to 5. Oops, that's an x. So the lengths of each side of the rhombus is 5 centimeters. Moving along. A man rides his bicycle due east at 16 kilometers per hour. So got a dude on a bike, and due east, remember your directions, north, south, east, and west. So he goes due east at 16 kilometers per hour, so he's going that way. His son rides his bicycle due south at 20 kilometers per hour. So this is at 16 kilometers per hour, and this is at 20 kilometers per hour. If they both leave point A at the same time, so this is point A, how far apart are they after 4 hours? Okay. Well, if this guy rides at 16 kilometers per hour for 4 hours, the distance he rides is equal to 16 times 4, or 64. So he's gone 64 kilometers. And then this guy's length, his son, would be 4 times 20, which is 80. So get it more to scale. Maybe I'll make this longer. You don't have to, but this is 80. And east and south meet at a right angle. Okay, so we got that going for us. Oops, kind of made it. And so it says, how far apart are they? So we're looking for x. So we know that 80 squared plus 64 squared is equal to x squared. And 80 squared is 6,400. 64 squared is 4096. That's equal to x squared. So you add those, that's going to be 10,496 equals x squared. We take the square root of both sides. 10,496 equals x squared. And to three significant figures, we get x approximately equal to 102. So they're about 102 kilometers apart. There we go. All right, and then I think we have one more example. Let's see. Yep, an equilateral triangle has sides of length 6 centimeters. Find its area. Equilateral triangle, that means all the sides are equal, and they're all of length 6. Okay. And we know the area is equal to 1/2 the base times the height. So we know that from here to here is 6. Okay, this is 6 over here, and this is 6 over here. So I know that the base is of length 6 if I think of this as the base. So 1/2 times 6. And the height would be this right here. I would drop a perpendicular from a vertex. That means it's a right angle. And if you drop the perpendicular from a vertex of an equilateral triangle, it bisects the other side. So in other words, this is equal to this, these little segments. So they're each half of 6 or 3. So to get this height right here, I'm going to redraw the triangle just so you can see it clearly. So the height of the triangle is here. This is 3. And this is 6, so that means that h squared plus 3 squared is equal to 6 squared. H squared plus 9 is equal to 36. Subtract 9, h squared is equal to 36 minus 9 is 27. So h is equal to the square root of 27. And then I can substitute that in for h. So that's 1/2 times 6 times root 27. And if you crank that in your calculator, rounded to three significant figures, 15.6 square centimeters. All right, so we can see how our good friend Pythagoras is quite helpful to us. That is all that I have. We'll go out with some more Love Spit Love. Bit of an obscure group. And with that, I am... Oh!